Lesson 3, scatter plots and lines of fit. So we'll start off with bivariate data that can consist of pairs of values. So bi means two variables. So we have pairs of values. Scatter plot is a graph of that bivariate data. You put it on a coordinate plane. The trend. When you look at the graph, what things do you notice? Do you notice it has positive or negative slopes, or instead of slopes, correlations? Is it a weak correlation? Is it a strong correlation? Okay, what things do you know about that data? Clusters are groups of points that go up or down, and outliers are points that are outside of that cluster. So if I look at a positive correlation, guys, it's like it has a positive slope. Okay? As the x increases, the y increases. Negative correlation. As the x increases, the y decreases. It gets smaller. This has no correlation at all because the x's and y's are not related to each other. Okay, so first things first, we're going to look at the football scatter plot. Oh, that came out bad. Scatter plot. The scatter plot displays the height and weight of New Orleans Saints football players. Determine whether the scatter plot shows a positive, negative, or no correlation. If the correlation is positive or negative, describe its meaning in the situation. So as you look at this, do you see any kind of correlation on this? Does it go up? Does it go down? Or is it just a bunch of numbers? Okay, so as you look at that. Okay. Oh, what did I do? Here we go. Okay, so as we look at this, it's not super duper clear, but it kind of sort of goes this way, doesn't it? So what it's saying is the taller the person is, the heavier they are. And that's talking about football players. Is it always true? No, it's not always true. We see some people that are tall that don't weigh as much, but for the most part in football, that is true. Okay, telephones. So here we are, we're talking about telephones. The scatter plot displays the number of landlines. And guys, if you don't know what a landline is, landline means that it's a telephone that's hooked to your wall at home. We have them at school. In the United States, in 100 million since 2000, determine whether the scatter plot shows a positive, negative, or no correlation, and then describe it. Well, look at this. It's going downwards. Okay? So this means it decreases. Okay, the y decreases. So that means that is a negative. You'd think I'd write better. Correlation. What does it mean? It means since 2000, there are less people with landlines. Okay, so next, lines of fit. So as you looked at these lines that I drew on these, they were not perfect lines with all of the data. So what we're going to be doing is we're going to use the lines of fit, and sometimes called the lines of best fit, but lines of fit. So we're going to make a scatter plot, going to plot each point of the data and determine whether there's a relationship. Is it a positive, negative, or no correlation? Then we're going to draw a line, and we're going to try and get one that follows closely with the data. Write an equation. You're going to pick 2 points, and then you're going to find the slope and the y-intercept. And remember, if there's no y-intercept, you can just use this formula, and that is called the point slope. We just pick a point and use a slope and find it. Then you'll make a prediction. So linear, I can't talk today, linear oh my gosh, I can't even say the word today. Extrapolation. I can't say that word today. I am so sorry. The use of linear equation to predict values that are outside the range of the values. Interpolation. I can say that one. I can't say the other one. The use of the linear equations to predict values that are inside the data range. Okay, so this is outside. So I can't say it. Okay, so boats, the table shows the average cost of a jet boat in the years after 2000. Write an equation to represent the data, then use the equation to predict the cost of jet boats in 2005. Okay, so over here we have year 0. So year 0, that's talking about 2000. So on our thing right here, I'm going to go up 0, 2, 4, 6, 8, 10. And we have to label what this is. Our X values are years since 2000. Years since 2000. Okay. And then over here, guys, we're starting with 17,000. So we don't want to start going up by ones. We need to go up by bigger numbers than that. So I'm going to go up by 5,000 each time. So this would be 20,000, and this would be 30,000, 40,000, and 50,000. And what is this? Cost in dollars. Oh, I misspelled dollars. Okay. So 0 is 17,663. 17,663 is about here. 1 is 19. Okay, so that's about here. 2 is 21. So somewhere right here. Then we go back down to 20. 4 is 23. So that's closer up here. 6 is 24. Oh, we skipped a number. That's why. 24. 7 is 27. Okay, then 8 is 28. Got to make this a little smaller so I can see. 28. 9 is 29. 10. Oh, I should have made this. Oh, well. 10 is 32. And I'll have to put 12 over here. 11 is 34. So it's halfway. So 34 is going to be about here. 35, so that's going to be past it. And then 37. Okay, sorry I didn't make my graph big enough. So I have a y-intercept, so I'm going to go ahead and use that y-intercept. I'm going to start here, and I'm just going to go up like so. So, looks about like that. Okay. Now, is it perfect? No, it's not perfect. So I'm going to pick 2 data points to use. Do I have to use my 0? No, I'm actually not going to use my 0. I'm going to use the 5. Why would I use 5? I'm not going to use 5. I am going to use 0, 1, 7, 6, 6, 3. And then where does it go through on here? It goes through 8, 30,000. I'm going to go through no, let's pick a different number. Let's pick one of these that it's actually hitting. That looks like it's hitting that one, so I'm going to use 10. There we go. That'll be good. 10, and it's 32,752. Oh, sorry, you can't see what I'm looking at. So I'm going to use this point, and I'm going to use this point, and I'm going to find the slope. Okay, so that's going to be 32752 minus 1763 over 10 minus 0. Let me get a calculator out. Now, could you come up with different numbers? Yes, because you may have used different numbers than I did. So 15089 over 10. So I would get 1508.9 as my slope. So then if I had an equation using this one, it would be 1508.9x plus 17663. Now, if I didn't use those two, and if I used 2 different points, if I had used 2 different points, so if I came over here and I used, let's see, if I use 423,280, that's good. And I don't know, I use 12, 35589. Okay, if I had done these two, 35589 minus 23280, and I do 12 minus 4. So I plug this into my calculator, 35589, 23280. I get 12309, and that's over 8, so divided by 8. And I get, my slope is 1538.625. Okay, so are my slopes close? Well, for the numbers we're using, yeah, they're pretty close. It's 30 off, okay? So it's gonna be a little off depending on which 2 points you decide to use. You wanna use points that are close to the line that you drew. But is your line the best line? It depends. We'll find that out later. We're not doing that right now. So if I was to use this slope, I would pick one of the 2 points. So I'm going to pick the first one, y minus 23280, that's an 8. Why did I draw that? Equals my slope, 1538.625, and that's x minus 4. So I multiply this out, and 1538.625 x minus, take this and multiply it times 4, and I get 6154.5. I add 2280, 280. And I get y equals 1538.625x plus 17125.2. Okay? So there we have it. We have two different ones. Now it says predict the cost in 2005. Well, if I use the first equation, I'm going to plug in 5 because it's how many years since 2000. So if I take my calculator, 1508.9, and I multiply that times 5, and I add 17,663, I would get 25207.5. Okay? Oops. If I did 2025, so that's 25 years difference. Okay, I'm trying to move. Oh, come on, iPad. It's not wanting to work. Come on. There we go. So if I was to use the first equation, y equals 1508.9 times 25 plus 17663. So I do the same thing and I plug it into the calculator. And I would get y equals 5538.5. Okay? Now, if I was to use the other equation, y equals 1538.625 times 5 plus 17125.5. Oh, I didn't leave myself very much room, did I? That's okay. 38.625 times 5 plus 17125 plus 5, or 0.5. I would have gotten 24818.625. Okay, so not too far off. Not too far off. So we'll do this for year 2025 over here, if I have enough room. 625 times 25. Oh, I'm going to have to put it down below. 1. There we go. And plug that into my calculator. I would get 55591.125. Okay, so I'm not off by that much. So they're about the same amount. Okay, so here we do this again. Okay, so we're going to do the same exact thing that we just did, but this time we're going to use the animals. Okay, so over here, I'm going to go up. This is going to be the weight on the bottom. And hopefully I did a big enough graph this time. 10, 20, 40, 50, 60. And then over here, we're going to do milk in ounces. And we're going to start at 0 and go 20, 40, 60, 80, 100. There we go. Okay, so it has 5 for the weight and 12. So 5 for weight and 12. That's going to be about there. 7 and 16. So 7 and 16. And then 10 and 20. And then 15 and 28. 15 and 28. 20 and 32. 20 and 32. 25 and 40. 25 and 40. 30 and 48. 30 and 48. 8. 40 and 64, 40 and 64. And 50 and 80, 50 and 80. Okay. So if we were to use, I'm going to use this data set and I'm going to use this data set. Why? I don't know. Sorry. That would be the line-ish. So I'm going to use those 2 points. Why? They're easy. So my slope would be 80 minus 20 over 50 minus 10. 60, 40, 6 over 4, which simplifies to 3 over 2, which is 1.5. Which point am I going to use? I'm going to use this first one. So y equals, nope, not y equals, y minus 20 equals, oh, I like 3 over 2 better. I'm going to use 3 over 2. X minus 10, again with the minus, equals 3 over 2. X minus 2 goes into 10 5 times, so that's 15. I add the 20 over, and I get y equals 3 over 2x plus 5. And if you want to write it as 1.5, that's the same thing. Okay? So, if I was to plug this in, this is the equation. I have 17 pounds. So I'm going to plug it in. Y equals 1.5 times 17 plus 5. So I take my handy dandy calculator. I put in 1.5 times 17 plus 5. And I would get y equals 30.5. So I made a prediction that that would be 30.5 ounces. Okay, so this one I plug in 55. Oh, really? To find out how many ounces. So I plug in my calculator and I get 87.5 ounces. Okay.